So in elasticity concept, after learning stress and the strain, so stress is the input for a body. Due to that, we get the change in the dimensions as the strain. Now, basing upon the stress and the strain, we study about three types of modulus of elasticities. One is Young's modulus relating to the longitudinal stress and longitudinal strain. Later, bulk modulus. This bulk modulus which refers to the volumetric stress by volumetric strain. Later, modulus of rigidity. This modulus of rigidity which explains about ratio of the shearing stress by shearing strain. Y is Young's modulus and K is bulk modulus. Eta is rigidity modulus. Young's modulus refers to the length of a body and bulk modulus refers volume of a body. Rigidity modulus refers the shape of a body. And which factors this elasticity will be get depend. Elasticity is not a permanent factor. It will be get changed basing upon the three factors. First one is effect of large amount of this stress and due to annealing and due to effect of temperature. Suppose if large number of stress cycles undergoes, there exists loss of elasticity property. So stress should be applied even within the elastic limit according to Hooke's law. Later, annealing the material. It results in formation of the large crystal grains which ultimately reduce the elastic property. Elasticity is not a permanent property. Later, effect of temperature. Elasticity increase with decrease in the temperature. So, for example, if the elasticity increases with the decrease in the temperature, then the elastic property increases when the temperature is decreased. The carbon filament becomes plastic at the higher temperatures. Later, already we discussed these are the two modulus with the units Newton by meter square because the formula is stress by strain. So this formula is for the stress. Strain has no units because change in dimension by original dimension. Both of them have same units. Units will be get cancelled. Now original formula for any modulus of elasticity is Newton by meter square. This Newton by meter square is for the stress. Strain has no units. So already we discussed longitudinal stress by longitudinal strain is Young's modulus. Volume stress by volume strain is the bulk modulus of the body. Later, where we apply this elasticity. So we learn in this lesson where we apply the stress, strain and the displacement distributions in all elastic body due to the external forces. Next one, there exists certain establishment of mathematical boundaries when we are learning this elasticity. So study about this elasticity outcome is in the engineering applications. We can use elasticity in the aeronautical and aerospace engineering branches and in the civil engineering branches, and we use them in the materials engineering and also in the mechanical engineering. In aeronautical and aerospace engineering, we apply this for the stress, fractures and fatigue analysis in the aerostructures. And in civil engineering, we apply this in the soil, rock and concrete structures. And in materials engineering, we use this elasticity nature for all dislocations in the structures and microstructures. And we also apply this elasticity for mechanical engineering to test the body, thermal stress analysis, and also for the fracture mechanisms. So this lesson explains about applications of elasticity and course outcome for the engineering applications. And in this lesson, we study about the advanced work undergoing in the elasticity and also in the inelasticity materials. So there is several applications which we use them in the plasticity, viscoelasticity and to study about the computational effects in these materials. So the main overview what we have learned in this present lesson is about different types of stress, deformations present inside the body and the solid, what is the effect of the solid properties due to applications of the force on these materials and which dimensions we